Hi, so welcome. Today we take a look at kinematics, which is a continuation from what we looked at before with the scalar and vector quantities and speed and displacement and velocity and so on. So here we look at the advanced side of it, where we have to look at how we go from displacement to velocity acceleration. So if you recall, we should remember that velocity, what's the fun of velocity again? Velocity is how displacement changes with time, and acceleration is how velocity changes with time. So if you look at this carefully, we all know that what does dy dx mean again? Dy dx means how y is changing with respect to x. So what will ds dt mean? How s is changing with respect to t. But then we know that as s and t changes, that represent velocity, right? And if v is changing with respect to t, then that must represent acceleration. Okay? So it means that we could link displacement, velocity, and acceleration by differentiation. So if I wanted to go from displacement to velocity, all I have to do is differentiate displacement. Take a look at it there. The differential of displacement is velocity. See that? So we go from here to here and we differentiate. So what will be the differential of velocity with respect to time now? Well, that will simply be acceleration. So to go from displacement to velocity, we differentiate with respect to time. To go from velocity to acceleration, we differentiate velocity with respect to time. So make a wild guess. How would we go from acceleration to velocity now? Well, to go from acceleration to velocity, yes, guessed it, we integrate. So if I integrate acceleration with respect to time, I'll get velocity. And if I integrate velocity with respect to time, I'll get displacement. Okay? But this is what you must remember. Differentiation, integration. Differentiation, integration. Okay? So there's one little thing that I must remember is instantaneous velocity occurs when v is 0. If a particle is moving up at its highest point, it experiences instantaneous velocity. It will go up. At this high point here, its velocity will be 0. That's called instantaneous velocity, or the point which it's at rest for a short period of time. Right? And the particle will stop there. Okay? And v is 0 up there. Right? So you can also make a note at highest point. Okay? So here's a simple example that we're going to look at. We have a particle that moves in a straight line with an acceleration given by this formula. And when t is 1, the velocity is 2 and is 5 meters away from O. Find the velocity when t is 2 and the displacement from O when t is 2. So let's put this in that simple diagram. Very simple diagram. The particle is at O, and somewhere along here it has an acceleration of 10t minus 1. Okay? Let's use two lines for the 2 arrows for the acceleration. Okay? And let's take the information the question gave us. It said when t is 1, v is equal to 2 meters per second and s is equal to 5 meters. Okay, that's it right here. So always underline and highlight all the important stuff. Okay, 5 meters from fixed point O. Okay, so at this point here we know t is 0, s is 0. Because if you start here, t will be 0 and the displacement will be 0. Okay, so that's all the information we have. Now we need to start working. So we know a is equal to 10t minus 1. Okay, so first part is to find velocity when t is 2. So we need to get velocity, but we have acceleration. So we know if I integrate acceleration with respect to time, I'll get velocity. So the integral of acceleration is 10t minus 1. What's the integral of 10t? Well, this is power 1 here, add 1 to the power, divide by the new power. What's the integral of minus 1? The integral of minus 1 is minus t. And don't forget, plus c. So you'll get v is equal to 5t squared minus t plus c. Right? This is not the full equation because we still have a c, so we have to work it out. How do we get c? We use this vital information here. Right? So b is equal to 2 by 5. T is 1. T is 1. And we can solve for c. So 1 squared is 1 by 5 minus 1. Right? This will be 2 minus 4, which is minus 2. So our actual equation really looks like this. Our actual equation is v is equal to 5t squared minus t minus 2. Follow that? So now we have the actual velocity equation. And now we can go back now and say, okay, so when t is 2, we can easily find velocity. That will be 5 by 2 squared minus 2 minus 2. 2 squared is 4 by 5 is 20 minus 4. So the answer is 16 meters per second. That's okay? Very good. Alright, so now to do part 2. So part 2 now we have velocity. So what we need to get now? We simply need to get displacement. Displacement is the integral of velocity with respect to time. So that would be the integral of 5t squared minus t minus 2 with respect to time. Okay? And before everything runs off the board and I can't see anything, let's shift it across here. So you'll get s. What's the integral of 5t squared? 5t squared add 1 to the power, divide by the new power. What's the integral of t? Add 1 to the power, divide by that. What's the integral of minus 2? Minus 2t plus c. So s is equal to 5 on t, t cubed, minus a half t squared, minus 2t plus c. Right? Same problem again. We need to get c. How do we get c? Well, they told us, I erased it, when t is 1, s is 15. When t is 1, s is 5. Okay? So it means 5 is equal to 5 over 3 by 1 cubed minus a half by 1 squared minus 2 by 1 plus c. So you should have your calculators close by. So 5 thirds minus a half minus 2 plus c. Right? And you should get your value for c. Right? C is equal to, you have now the answer for c is 35/6. So therefore, s is equal to 5/3 t cubed minus a half t squared minus 2t plus 35/6. And the question asks displacement from O when t is 2. So you simply have to write 5/3 by 2 cubed minus a half by 2 squared. Right? And we have our answer. So see how simple this could be once you remember this. Displacement to velocity we differentiate, velocity to acceleration we differentiate, acceleration to velocity we integrate, then we integrate again. Okay? So that's it for Kinematics.